Hi, I'm Joe, and this is my van.
Hi there, welcome to my channel. My name is Joe, and this is my van. Today, we're going to be talking about the overall electrical system and how everything works together. You might be saying, Joe, why has it been so long since the last video? Well, I'll tell you, I've been really busy. We've had some really good contracting projects come up lately. We've had some outdoor projects, and we've had some really good painting projects. We've already covered how the solar panels and the battery banks work. Now, let's look at the 3 different charging systems I installed and how everything gets connected. I also had time to create an electrical diagram. You can check this out on my website at defonsodesign.com. The first component to look at is the Victron Lynx distributor. This essentially is a bus bar for the whole electrical system. The batteries are connected to one side, and every other component like circuit panels and charging devices are connected respectfully to their positive and negative terminals. There are some major advantages to using the Victron system. One of which is each component can get connected to the Victron Lynx distributor in a dedicated location and also is provided with a fuse. The Lynx distributor can also be connected to other Victron products for battery monitoring and system maintenance. On the front end of the electrical system, I installed the BMV712 Victron battery monitor with smart shunt. Inside the Lynx unit, we see the positive side, the negative side, and the fuses, which are wired in line with the positive leads. Here we also see the main system switch, the Victron battery monitor system smart shunt, and the ground connection to the Ford Transit chassis. Inside the unit, if we look at each component, we can see the inverter charger, the DC-DC alternator charger, the AC system ground connection, the solar charger, and the DC circuit distribution panel. There are also a few utility connections throughout the unit with inline fuses. All connections here were made with the hydraulic crimp and heat shrink. Most of the components I used in my build were Victron Energy, one of the leaders in off-grid power solutions. Between the Victron and the Blue Sea systems, who specialize in marine power, I felt I built a very robust system which hopefully should last a long time. The first charger system we're going to look at is the AC power system. Victron makes the Multiplus 2 3000 watt inverter charger. This unit takes care of all power management from 120 volt to 12 volt and vice versa. The unit has a little bit of weight to it, so securing it to the storage box I built was important. I left the unit accessible to prevent overheating and access to the switch. The Multiplus 2 is wired to the AC distribution panel with 6-3 wire. From there, we have a few circuit runs to outlets throughout the van for 120 volt appliances and convenience. The outlets are wired with 12-2 wire. The Multiplus has the ability to charge the battery bank from 120 volt to 12 volt. This is what's referred to as shore power and can be provided at campsites or any main hookup. I had to install a power inlet on the side of the van. Picking a location was easy. I used the rear driver's side and cut the hole with a sharp new hole saw. I cut a wood backer and through bolted the inlet to the van side. I used butyl tape and roofing sealant to seal the outside. On the inside of the van, I wired the inlet to a 30 amp breaker switch. The breaker switch then travels to the Multiplus unit, and all these connections were made with 10-3 wire. Inside the Multiplus was very easy to work with. The only other connections needed were a system ground, which traveled to the Lynx, and the installation of the Victron Bluetooth dongle. The dongle allows the Multiplus to communicate with the Victron app, and that allows me to monitor everything right from my phone. The next charger in this system is the Victron Smart Solar Charge Controller. The sun and the clouds are constantly changing, and that's going to constantly change voltage going to the batteries. In order to keep a safe system and to keep consistent energy going to the batteries, we install a solar charge controller. This unit can handle accepting up to 100 volts from the solar panels at a time and outputting up to 50 amps of 12 volt power to the batteries. For our build, if we have 3 panels that can have a maximum output of 22 volts each, plus or minus 5%, we know that the panels wired in series will only have a maximum output of 66 to 70 volts, well within the limit of the unit. All the technical information for the solar panels should be clearly stated in the manufacturer's specifications. Wiring the unit was very easy. The positive and negative leads from the solar panels travel through the disconnect switch and get connected to the input of the solar charger. The output of the charger then goes to the Lynx distributor and passes through an 80 amp megafuse. The next charging system we're going to look at is the Victron Orion DC-DC charger. This device allows the lithium battery bank to be charged from the Ford Transit battery bank while the engine is running. The Orion unit is connected to the Lynx unit and has a 60 amp megafuse in line. The off-grid batteries are often referred to as leisure batteries, and the vehicle battery is often referred to as the starter battery. Having a charging system like this will be a huge benefit for me, especially on days I'm traveling and the sun is not shining. In general, the positive lead connects to the positive terminal of the starter battery. However, Ford provides a very specific connection point for this exact function. The connection point is rated for the correct amperage and will only work while the engine is running. There is a 60 amp MIDI fuse in line with the positive lead. Some additional features I added were a 12 volt cooling fan for the unit, since it does heat up during long use, and a couple switches by the driver's seat. Installing an on-off switch for the unit required removing the small green plastic piece and running a wire to a switch. It's very simple. Some of the protection I put in for this build was a little bit redundant, however, I do feel it was worth the time to put in these safety measures. The final spot in the Lynx distributor is the DC branch circuit panel. This panel distributes all the 12 volt power to the 12 volt lighting and appliances. Now I know I should have had these breakers sized appropriately and not have all 15 amp breakers in this panel, but I have made the appropriate measures to space out the amperages across the circuits fairly evenly as to not overload one circuit at a time. Breakers include LED overheads, LED strip lights, LED bed lights, vent front fan, vent rear fan, refrigerator, and a few spare circuits with wire runs for later installs like water pump and water heater. Once I knew everything was working properly, it was time to start sealing up the wires and the electrical box. I utilized some of the extra space to store tools and cables. I built slider panels for easy access and reinstalled the E-track for work materials. I added a hinge top for easy access to the battery bank and storage. This electrical system took a lot of time and planning. I prepped list after list and double-checked all my components and parts. Well, that's it for now. I'm happy to say the electrical system is working and the refrigerator is keeping the drinks cool. It's been really hot this summer, so having an onboard refrigerator has been such a lifesaver. After this is going to be the plumbing system, and that's up next. So stay tuned and come back for more. We'll see y'all later. Check 2.